Welcome back to Elements of Civil Engineering and Mechanics class. Now I am going to discuss about parallel transfer of force. So that is parallel transfer of force. What it means? Let me consider a force F, say acting at point A. So I need to transfer that force to point B. So let L be the perpendicular distance between the line of action of the force and the point B. I am going to write that as L. So what is the meaning of parallel transfer of forces? So that is nothing but what is the effect of this force on this point. So for that, to find out what is the effect of this force on this point or to do parallel transfer, so the next step I am going to do is here A this is L. So I am going to put two forces at point B of magnitude F, this F. So that is F. And these two forces are equal and opposite, and these two forces are parallel to the original force. So if I take this system of forces, what happens is these two forces F and F separated by a perpendicular distance of L makes a couple. So that is, this is point A, this is point B, this is distance L. So this force, these two forces and the perpendicular distance couple of magnitude F L. So this is a clockwise couple, that's why I have written clockwise moment, and this force remains. That is, the force F remains. So what it means is, if I apply a force F at point A, the effect of that force on point B is, it is going to create a moment of magnitude FL, as well as it is going to apply a horizontal force of magnitude F. This is parallel transfer of force. I am going to repeat. So I am going to transfer this force to the point B. For that, so I am going to put two equal and opposite forces at point D, and these two equal and opposite forces are parallel to the original force which we are going to transfer to the point B, and the magnitude will be the same. Then these two forces, equal and opposite forces, separated by a distance L, form a couple of magnitude FL. So I am going to put that FL here, and this force F remains as it is. So this is the effect of this force acting at A on the point B. Next, before we start solving the problems, so we are going to follow certain sign conventions, and I have explained about sign conventions already. So I am going to do it once again, that is sign conventions. So this is positive, this is negative, this is positive, this is negative, this is positive, and this is negative. That means when we are solving problems, here we are going to resolve the forces. So when we resolve the forces, when we add the forces algebraically, then we need to follow certain sign conventions. If the forces are horizontal, so those forces may be acting to the right or to the left. So we are going to set a sign convention. So those sign conventions are all forces acting towards right are positive and all forces acting towards left are negative. Similarly, if we take the vertical forces, so we are going to follow the sign convention of all forces acting upwards as positive and all the forces acting downwards as negative. So this is regarding the forces. When we come to the moment, so whatever positive, that is whatever the clockwise moment, or if any force causes a clockwise moment, so that moment is considered as positive and counterclockwise or anti-clockwise moment as negative. These are the sign conventions we are going to follow. If you want, you can reverse the sign convention. You can take this as negative, then this will become positive automatically. Similarly, you can take this as negative, finally then this will become positive automatically. If you take this as negative, this will become positive automatically. So whatever way you are comfortable with, you can take that sign convention, but here we are going to follow these sign conventions. I hope this is clear. Thank you. Next, we shall solve some problems. This is regarding resolution of forces, that is numerical problems. So that is, find the x and y components of the following forces. Find the x and y components of the following forces. So this is A, so that is 10 kilonewton at an angle of 30 degree. So I need to resolve this force horizontally, that is along the x direction, and vertically, that is along the y direction. So this is my reference axis, x, this is y, this is the origin, okay, and this becomes point O. So to resolve this force, what I do is I am going to complete this rectangle, and I am going to call this horizontal component as Fx and the vertical component as Fy. So when we resolve the force, so what we need to do is, if this is Fx and the vertical component is Fy, when we start from the tail end, then if you go horizontally, this is the way the arrow comes. When we take the vertical component, again if you continue vertically, this becomes up. So because this is a rectangle, so this will also be Fx and this will also be Fy. So here Fx is the horizontal component and Fy is the vertical component. So let us find out these two values. If I consider this triangle, which is a right angle triangle, then cos 30 equal to adjacent side, that is Fx divided by the hypotenuse, which is the main force of 10 kilonewton. Therefore, Fx equal to 10 cos 30. Fx is positive. The reason it is positive, because this is acting towards right. So when this is acting towards right, according to our sign convention, any force, any horizontal force acting towards right is positive. So this is 10 cos 30. That is nothing but Fx equal to, so I am going to take this positive out. Finally, when I write the final answer, so we must write this. This should be the final answer. Show the arrow here. That means the resulting force, the component force Fx is acting to the right. Next, when it comes to the vertical component Fy, take sine 30 equal to opposite side by hypotenuse. Opposite side is Fy, hypotenuse is 10. Therefore, Fy equal to 10 sine 30 with plus sign. So if I don't put anything, by default it is plus. So what it means? The vertical component is acting upwards. That's what plus means. That is Fy equal to 5 kilonewton. Okay. So because this is plus, so finally when you write the answer, you must show this sign. And as I explained in the previous class, you keep one thing in mind. So instead of considering this triangle, taking cos theta equal to adjacent side by hypotenuse, sin theta equal to opposite side by hypotenuse. If you are solving a problem, if you want to do it quickly, so what you can do is, any component adjacent to the angle theta is always cos. You keep that in mind. So here, what is the component? Fx is the component of this force, that is the horizontal component of this force, F, 10 kilonewton. This is adjacent to angle 30, so that should be cos. So you can directly write this as cos 10 cos 30. Similarly, any force away from the angle is always sine. So that's why if you look here, this is sine 30. So Fy equal to 10 sine 30 with plus sign. So vertical force with plus sign means it is acting upwards. So whenever you are expressing any result, so you must show this. You must strip these values of all signs. If it is negative, just take out that sign and show the arrow. Again, if it is positive, take out the sign and show the arrow properly or accordingly. I hope this is clear. Let me take the next problem, problem B. This is 1000 Newton. This makes an angle of 30 degree with respect to the vertical. So if this is X, if this is Y, so if this is O, this is O, this is 1000 Newton, this is 30 degree. That is given. So as I explained in the previous problem here, horizontal component, in this case Fx, so this is away from angle theta, that is 30 degree here. So once this is away from this angle, so horizontal component is always 1000 sine 30. So vertical component, this is adjacent to the angle 30 degree. So it is 1000 cos 30. When it comes to the arrows, so why can't we show the arrow like this? Why can't we show the arrow like this? Sorry, arrow downward. So those are the things you can, or those are the doubts may come up in your mind. So whenever you resolve a force, you keep in mind that because this force is attached to point O, if you are finding out the horizontal component, so keep this fixed because the arrow is attached to the point O. Then rotate it, make it horizontal, and when you rotate it, the angle of rotation should not be greater than 90 degree. So when you rotate it, make it horizontal, look at the arrow how it is acting. This is acting to the left. Similarly, when you are finding out the vertical component, so rotate it in the vertical direction, towards the vertical direction in such a way that the total angle of rotation is not greater than 90 degree. So of course you are rotating only by 30 degree here. So when you rotate it, how the arrow is acting? It is acting upwards. So that is the way you can imagine and you can solve the problems very quick. Okay. So coming back to this once again. So horizontal component Fx equal to, look here, what is the horizontal component? 100 sine 30. What is the sign? How the force is acting? It is acting to the left. So according to our sign convention, it is minus. Okay, 100 sine 30. Sine 30 is half. So 100 sine 30 is 500 with minus sign. So with minus sign means, as I said, it is acting towards left. So take that minus out. Finally write the result. Okay. When you take this minus out, you must replace this minus with the direction of the force, that is the direction of the component force. This is Fx. And vertical component Fy equal to, this is 100 cos 30. So how it is acting? It is acting upwards. According to our sign convention, it is plus. Even if you don't write anything, by default it is plus. So it is 100 cos 30 is 866 Newton Fy. So finally, when you write the final result, you must write 866 Newton and you must show this arrow as acting upwards. So this is the vertical component. Let us go with the next problem. Problem C. There is a force acting. The problem is given like this. Sorry, this is y direction, this is x direction, and there is a force acting like this, and the magnitude of the force is 20 kilonewton. And the slope of this force is 4 horizontal and 3 vertical. So I need to find out what is the component of this force in the horizontal direction and in the vertical direction. So what I do is, I am going to take this triangle, right angle triangle. So I am going to write this separately. this is 3, this is 4. So by applying Pythagoras theorem, so this becomes 5, that is square root of 4 square plus 3 square, that is 25. Square root of 25 is 5 units. So if I call this as theta, then this is theta as well. When this is theta, this should be theta as well, because they are alternate angles. This line is parallel to this. So this is the line cutting these two parallel lines. This theta and this theta are alternate angles. So first, you can find out what is theta, or else, because we need cos theta and sin theta, we can directly find out what is sin theta and cos theta from this triangle. So from this triangle, what is sin theta? Sin theta is sin theta equal to 3 by 5, that is opposite side by hypotenuse, that is 0.60, and cos theta is 4 by 5, that is equal to 0.80. Now, I am going to resolve this force. So for that, what I do is, again I am writing this figure once again. This is x, this is y. So if I take the horizontal component, so as I said, if I call this as O, so make it horizontal, turn this with tail end fixed. So move this arrow such that the angle of turning is not more than 90 degree. Of course, if you turn this way, then the arrow will direct this way, but the angle is more than 90 degree, so which we should not do. So if we turn this way horizontally, then the component force will become like this, Fx. So vertical component, if you turn this way, this will become Fy. Okay. Next, what is the magnitude of Fx? Fx is, see if you look here, theta, and the horizontal component is here, and the horizontal component is adjacent to the angle theta. So it is 20 cos theta. Similarly, if I take the vertical component, this vertical component is away from the angle theta. So vertical component is 20 sin theta. Therefore, horizontal component Fx equal to 20 cos theta. Okay, and what is that? What is the sign for this component? It is acting to the left. It is minus, according to our sign convention. That is minus 20. What is cos theta value? So what you can find out is using the formula tan theta equal to 3 by 4. Therefore theta equal to 36.86 degree. Then if you substitute 36.86 degree, so you are going to get 0.6. If not exactly 0.6, you may get 0.60002, something like that. Because 36.86 is not the exact value. It is rounded up to the second digit or second decimal place. Instead, as I said, you can directly make use of this value cos theta equal to 0.80 here. So that is 0.80. That is minus 16 kilonewton, or Fx equal to 16 kilonewton. Once I strip this minus, I should replace this minus with an arrow sign, that is acting to the left. And vertical component Fy equal to, again, 20 sine theta. What is the sign? Minus sign. Why it is minus? It is acting downwards. So that is equal to Fy equal to minus 20. Sine theta is 0.6. Okay, that is equal to 12 kilonewton. So Fy equal to 12 kilonewton. Once you take out that minus sign, that should be replaced with the direction which is downwards. So this is a vertical component. I hope this is clear. And let me go with the next problem. Let me give 1 or 2 minutes to write down. This is about resolution of force. Let us take an example on composition of forces. The problem goes like this. This is about composition of forces. The problem says the figure shows four forces, 8 kilonewton, 10 kilonewton, 20 kilonewton and 2 kilonewton acting at point O. Point O in the same plane. Determine the direction and magnitude of the resultant force with respect to the reference axis. With respect to the reference axis. So these are the four forces we have. This is the y direction. There is a force acting here. Eight kilonewton at 45 degree. And 2 kilonewton at 30 degree. 20 kilonewton, 30 degree. and 10 kilonewton again at 30 degree with respect to the vertical. So let us read out the problem once again. The figure shows 4 forces, 8 kilonewton, 10 kilonewton, 20 kilonewton and 2 kilonewton acting at point O. So this is the point O. In the same plane is nothing but this force system is a coplanar force system. So determine the direction and magnitude of the resultant force with respect to the reference axis. So we have two reference axes, that is one is X and the other is Y. I need to find out the resultant of these forces with respect to this reference axis. So that means I should replace these forces with a single force called the resultant, and that will have the same effect as all these forces combined. So the first thing I need to do is, before finding out the resultant, the first thing I need to do is I need to resolve all the forces. Here all the 4 forces in the horizontal and vertical directions. Okay, once that is done, then I am going to find out the resultant and the direction of the resultant. To start with, let me write this equal sign. Again same, the reference y-axis. This is x-axis. Let me take this force 8 kilonewton. So if I resolve this force horizontally and vertically, in this case not the tail end but the head end of this force is touching the point O. That is, that force is acting at point O. So then this, with this end fixed, I am going to move the tail horizontally and vertically. So if I move this and make this horizontal, then the arrow will be acting towards left. That means the horizontal component of 8 kilonewton is acting towards left. So this is 8 kilonewton horizontal component. So what is the magnitude of the horizontal component of 8 kilonewton? So because the horizontal component, that is this, is adjacent to angle 45 degree, as I said in the previous example, it is cos 45. So horizontal component is 8 cos 45. Next, what is the vertical component? Again, keep this fixed, move the tail vertically. It is 8 sin 45 because this component is away from the angle 45 degree. So away from means it is sine. Coming to this force, that is 2 kilonewton. So 2 kilonewton horizontal component is here acting to right 2 cos 30. And how about the vertical component? Again, keep this fixed, move the tail. So this is acting downwards. That is 2 sin 30 degree. Next, coming to this. What is the horizontal component? That is 20 cos 30. 20 cos 30. And the vertical component is 20 sin 30. Coming to this force, what is the horizontal component? horizontal component is 10 sine 30 acting towards left, that is 10 sine 30, and what is the vertical component? That is 10 cos 30 acting upwards. So now we have resolved all the forces horizontally and vertically. So let us add them algebraically in each direction, that is along x-axis and along y-axis. So algebraic sum of horizontal components of all the forces, I am going to call this as sigma fx because this involves more than one force. Sigma fx equal to, let us see what are the horizontal forces acting here. We have 4 horizontal forces. So let me go with this 20 cos 30. What is the sign? It is plus because that force is acting towards right. So it is 20 cos 30. Next, let me take this force. Again acting towards right, 2 cos 30. How about this force? The horizontal component, this force, look at the arrow, this is acting towards left. So when this is acting towards left, it is minus 8 cos 45. And one more force acting towards left, that is minus 10 sine 30. So if you calculate what is sigma fx, so the answer is plus 8.4 kilonewton, plus 8.4 kilonewton. So when it is plus 8.4 kilonewton, it is sigma fx equal to 8.40 kilonewton, and the arrow should be acting towards right. And algebraic sum of vertical components of all the forces so I am going to call this as sigma Fy, that is equal to, so let us take all the vertical forces here acting. 2 sine 30, 2 sine 30, what is the sign for 2 sine 30? This should be negative because that force is acting downwards, that is minus 2 sine 30. Similarly, we have one more force which is acting downwards, that is minus 8 sine 45. One force acting upwards, so that is plus 20 sine 30 acting upwards, 10 cos 30, that is plus 10 cos 30 degree. So that is sigma Fy equal to, so we are going to get this as plus 12 kilonewton. Plus 12 kilonewton is sigma Fy equal to 12 kilonewton acting upwards. Okay. So these are the algebraic sum of all the horizontal components of all the forces. Similarly, this is for the this is in the vertical direction. So I need to find out what is the resultant of these two forces. So resultant of these two forces is the final resultant value, that is the resultant of all the forces put together. So for that what I do is I am going to write the forces here, that is sigma Fx of magnitude 8.4 kilonewton See, look at this arrow acting to the right. That's why I have shown this force as acting towards right. So 12 kilonewton, it is acting upwards. This is acting upwards. So that is sigma Fy equal to 12 kilonewton. And of course, this is the point O, because when all these forces are acting at point O, the resultant should also be acting at the same point. So after writing this, I am going to complete this rectangle. And if I join this diagonal, this is going to be the resultant. Let theta or alpha, whatever angle, be the angle the resultant makes with respect to the x-axis. That is, this is x-axis, this is y-axis. So we need to find out theta as well. When you find out r, that gives the value of the resultant, and when you find out theta, that gives the position of the resultant with respect to the point O. So let us find out. Therefore, the resultant R equal to square root of sigma Fx square plus sigma Fy square. That is equal to square root of 12 square plus 8.40 square. So the value of the resultant is 14.65 kilonewton. 14.65 kilonewton is the magnitude of the resultant. I cannot show the direction of the resultant yet. So I can only show the direction of the resultant only after knowing the angle theta. So, and tan theta equal to sigma Fy divided by sigma Fx. Sigma Fy is 8.40, sorry, sigma Fy is 12 divided by, and Fx is 8.40. Here there is a little correction. I make 8.40 square and this is 12 square, and final answer is the same, of course. So tan theta equal to 12 divided by 8.40. Therefore theta equal to 55 degree. Therefore the resultant of all forces, all the forces, I am going to call that as R, equal to 14.65 kilonewton, and I am going to write this figure. I am going to call this as R, and that makes an angle of 55 degree with respect to the horizontal. That gives the direction of the resultant. I hope this is clear. I think we are done for this class. So please write down.